Hey everyone, what's going on? Welcome to Focus AI. So here in this video, we will check what is the time and space complexity in logistic regression, specifically while in production, that is at the inference time, that is runtime. Okay. So space complexity is order of D, where capital D is the number of dimension of feature vectors. Why? Because we are only storing the optimal W, right? The weight vector. Because once we have the weight vector, that means we have the hyperplane, right? And once we have the weight vector, we have to just do the dot product with the features of the query vector, right? So the only thing we have to store in memory is the weight vector. So if the feature dimension is say 100, then we have to only store something like a list of 100 elements, right? So we have to store only something like a list up to 100 elements. So that is, I mean, that's it. So that's why the space complexity is order of D. Okay. Now coming to time complexity. Time complexity is also similar order of D, where D is the number of dimensions of feature vectors. Okay. Why? Because you have a query point XQ. So that means it is the features of your query point, right? This is a vector. W is also a vector. What you have to do, you have to compute only the dot product. So dot product means you are actually doing d multiplications and d minus 1 additions, right? It is actually summation, right? You are doing element wise multiplication and then summation. That is the dot product, right? You have W vector, you have XQ feature vector, and you are just doing the dot product. So the time will be taken just to compute the multiplications and additions, right? So which is I mean tremendous. Like for KNN, we have seen that we have to load all the training data in the memory. I mean that was humongous. But here you just need a simple space, a very small space just to store a d-dimensional vector. And also due to the very less time complexity, logistic regression used in low latency applications, like whether within a 1 millisecond, say within 1 millisecond a user needs his response. So a logistic regression model will be deployed, and the user will give some query point, it will immediately give the prediction, right? So basically, if D is small, we can readily use logistic regression in production system. But if D is large, say tens of thousand, okay, so tens of thousand or say 10,000 is the feature vector dimension, then it's anyway, there won't be a problem of storing 10,000 dimensional vector. That is absolutely fine. But I mean, for low latency application, it might not be useful. But yes, there is a hack, or actually, there is. I mean, that's not a hack. That is a proper conception by which you can reduce the time complexity as compared to 1,000 dimensional. How? Instead of using L2 regularization, you have to use L1 regularization. Why? Because if you remember, when you are using L1 regularization, it creates optimal W, that is weight vector, which is sparse. That means most of the 10,000 elements in W, very few element will be having some value, floating point value. Rest maximum, uh, maximum value will be zero, right? So obviously, if out of 10,000, if 8,000 values are zero and only 2,000 values are having some numerical value, then only 2,000 multiplication and 1,999 additions you have to do, isn't it? So that's why generally what machine learning engineers used to do, if they have to deploy a logistic regression model which requires low latency output, and in the meantime the dimension is very large, they actually use L1 regularization while training, because it creates a sparse weight vector and drastically the time complexity reduces. Okay, so this is something about the space and time complexity at the inference time for logistic regression. So in the next video, we will see how we can uh, do multi-class classification using logistic regression. So if you like the video, do subscribe my channel, share with your friends, and till then, have a nice day and happy machine learning. Thanks a lot.